In this detailed example, we're going to look at measures of association for nominal and ordinal variables. And we're going to use the random sample of 20 cases from the 2012 General Social Survey. And so we're going to look at relationships between two sets of variables. The first is going to look at the relationship between sex and attitude towards abortion. And the second is going to look at the relationship between health and happiness. And so let's start by just hiding all the variables that aren't going to be used in the first example. And so if I highlight them and I right-click Hide, I'm left with just two variables, sex and attitude towards abortion. And so we can start here by creating a bivariate frequency table so that we can calculate lambda, the measure of association for nominal variables. We saw in an earlier detailed example how we can do this by hand, but it turns out that we can also use Excel's built-in pivot table feature to create this table. And so if we just go up to the ribbon here and we go to Insert, and then we go to Pivot Table, we can put in the pivot table. And the first thing that we need to do is specify the data range. So we're just going to highlight the values of sex and attitude towards abortion. Okay. And then we just need to figure out where to put the table. And so we can put it in an existing worksheet. I already have a location for it. So I'm just going to click OK. And we're on our way to building this table. Now the next thing we need to do is we need to populate the table with some values. And so sex is going to be our column or independent variable. Our row variable is going to be attitude towards abortion. And so we're going to put that in the rows. And then we also need to have some values for the table. And so we're going to go up here and move sex into the value area. And we want to make sure that we change this so that it doesn't have the sum of sex, but instead it has a count. So we'll change the value field setting from sum to count, and we'll click OK. And so now we have a pretty good looking table of the relationship between sex and attitude towards abortion. And so we might just want to copy and paste this, and we can go up here to where it says paste values, so that we just get rid of some of the formatting that Excel automatically puts in. So we can actually delete the old table. We don't really need it anymore. And we can just use this because this has all the values that we want. So now let's change a few of the labels here. So this is our dependent variable, attitude towards abortion. And it turns out that yes is 1 and no is 0. Males are 1 and females are 2. And we can just resize this a little bit. Okay, and notice that there's nobody in this cell, so we can just put a 0. And if we wanted to, we can just kind of align these differently so they're a little easier to read. Same with these values. Okay, so how do we calculate lambda? Well, we need two values. We need E1, and this is the errors in estimation that we make when we ignore the independent variable, only look at the dependent variable. And we need to get E2, which is how many errors in prediction that we would make if we use the additional information on the independent variable and we don't use the information just on the dependent variable. So let's start with E1. We have to look at the dependent variable and figure out what's the modal category. So our dependent variable in this case is attitude towards abortion, and people can either be in support of abortion or not. And so here's the univariate frequency distribution for support of abortion. And so you can see that out of the 20 cases, 6 do not support and 4 do support abortion. So we have to ask ourselves, what's the modal category in this case? And so we can see that the modal category is no. And so how many errors would we make if we assume that everybody said no? And so basically, we would just subtract the modal frequency from the total number of cases to get E1. And so that would be equal to 20, in this case, minus 16. And so we make 4 errors there. Now we have to do the same thing for men and women. Let's start with men. What's the modal frequency for men? Well, it's no. And so how many errors would I make if I assume that all men don't support abortion? Well, you can see that there's 10 men, and 10 of them don't support abortion. And so if I take 10 and subtract 10, I see I make 0 errors. Well, what about women? Well, it looks like of the women, 6 of them don't support abortion, and 4 of them do support abortion. And so if I assume that all of them don't support abortion, how many errors do I make? Well, again, I would take the total number of cases, 10, and I would subtract the modal frequency, which is 6, and I get 4. And so now I would just add all of the errors that I would make across the values of the independent variable, and that comes out to 4. And so now we can use the formula for lambda to calculate the actual statistic. And so that would be equal to E1 minus E2, and then that value is going to be divided by E1. And so you can see here that the value is 0, and so that means that having some information about somebody's sex gives us no utility in predicting their attitude towards abortion. In other words, these two variables are completely unassociated. And so typically lambda gives us some value between 0 and 1. 0 means that there's no association. 1 means that there's a perfect association. We can express that as a percentage. And if it's closer to 0, then of course there's a weaker association. Closer to 1, there's a perfect association. And basically the number itself tells us how much utility we have in predicting the value of the dependent variable, given the value of the independent variable. And in this case, there's no utility. So knowing something about somebody's gender doesn't help us at all in predicting their attitude towards abortion. Advancing this detailed example forward, let's move on to our second example, the relationship between happiness and health. And so notice that I've now just hid all the other variables except health and happiness, and I've used Excel's pivot table to create a bivariate frequency table of health as an independent variable and happiness as a dependent variable. And notice that I've edited for content a little bit just to make it a little bit easier to use. Okay, so which measure of association should we use for these two ordinal variables, health and happiness? Well, it turns out that gamma is the appropriate measure of association in this case. And so how do we calculate gamma? Well, the first thing that we need to do is we need to figure out the number of same order pairs, ns, and the number of inverse order pairs, nd. And so we can do that basically by first figuring out where on our table we have the positive and negative direction for these two variables. And so we're going to ignore these numbers just for the moment. We're only going to look at the actual categories of the variables. And we're going to identify for both the high category and the low category. And so for health, high health is going to be excellent, and fair health is going to be the low category. And for happiness, very happy is going to be the high category, and pretty happy in this case is going to be the low category. And so where do we find the positive association on this table? Well, it's going to be from the upper left-hand corner to the lower right-hand corner. And why is that? Well, that's because that's where we find that low values of both health and happiness are changing to high values of both health and happiness together. In other words, as we go from low health to high health, we're also going from low happiness to high happiness. And so this direction is the positive direction. What about the negative direction? Well, that's going to be from the bottom left-hand corner to the upper right-hand corner. And that's because that's where we're finding that as values of happiness are increasing, values of health are decreasing, and vice versa. And so to calculate the same order pairs, therefore, we would start at the upper left-hand corner. And so for this cell, any cell that's below and to the right is going to have a positive association. And so what I need to do is I need to take the cell contents of these cells, add them together, and multiply them by the contents of this focal cell. Put differently, I just have to use some kind of a formula that tells me that I have to take this value and multiply it by the sum of this value and this value. And that's my first same order pair. But I'm not entirely finished yet. There's more cells that I have to look at. So for example, this cell has a positive relationship with this cell. And so again, I'm going to take the contents of that cell and I'm going to multiply them by the contents of any cell that's below and to the right. In this case, only this cell. And so when I do the arithmetic there, I get a value of 2. And so now I can look to see if there's any other cells that I have to worry about. And I'm going to go onto this cell, and I see there's nothing below and to the right. So remember, I ignore the marginals. So I don't have to use this cell in the calculations. Notice also that these cells have nothing below and to the right except marginals. And again, I don't use those in the calculations, and so I can skip all the rest of the cells. Now what I need to do is get the sum of all of the same order pairs to get the number of total same order pairs. So I'm just going to add up the value of this cell and this cell, and I'm going to get 26. So the number of same order pairs in this case is 26. Now that I've got the number of same order pairs, I can get the number of inverse order pairs. And I would start at the top right-hand corner. And I'm basically going to take the product of this cell's contents times the sum of the values of any cell that's below and to the left, which in this case is these two cells. And so I'm going to basically take the focal cell's contents and multiply them by the sum of this cell and this cell. And that gives me 0, of course, because I'm multiplying by 0. Now I move on to this cell, and this cell has a negative relationship with only one cell, this one. And so to get the next inverse order cell pairs, I'll take this and multiply it by this. Okay. Notice that this cell has nothing below and to the left, so I can skip it. And notice that the cells in this row have nothing below and to the left, except marginals, but those aren't used in the calculation. So now I can calculate my total inverse order pairs by taking the sum of these two values. So that gives me 5. And so I see that I have 26 same order pairs, 5 inverse order pairs. So now how do I get gamma? Well, gamma is calculated by taking the difference between the number of same order pairs and inverse order pairs and dividing that value by the sum of same order pairs and inverse order pairs. And so in the numerator I have 21, in the denominator I have 31. And so if I divide 21 by 31, I get a value of 0.67. And I can just multiply that by 100 to express it as a percent. It comes out to about 67.7%, or if we round it, maybe 68%. So what does that tell us? Well, that tells us that there's a positive association between health and happiness. And so as somebody's health increases, so does their happiness. And that makes sense. It seems to comport with our intuition about the relationship between these two variables. We can also see that this number is closer in absolute value to 1 or 100% than it is to 0. And so we can say something about the strength of the association based on how far away it is from 0 or 100%. And so since this is closer to 100% than it is to 0, we would say that this is a sort of a moderate to strong association because it's actually sort of close to the middle, about 50%. So it's sort of in the middle, but closer to the upper side. So I would call this sort of a moderate to strong relationship. Now, what about the number itself, 67 or 67.7? What does that mean? Well, that tells us how much better our guess about somebody's happiness is if we know their health. And so we can say here that our prediction of their happiness is 67% better, almost 68% better, if we know something about their health than if we don't. And so we can see that this is a fairly robust association here.